Okay, this is lesson 3.4 on exponential and logarithmic functions, or exponential and logarithmic equations. Okay, so on the screen we have a couple of important properties. The first one being that if we have two exponentials with the same base, then we know that if the bases are the same, we know that the exponents have to be the same. Same with logs. If we have log base a of x equals log base a of y, then we know that x and y have to be equal. We have the inverse properties right here. We know that we can take the log base a of both sides to get rid of an a to the x. We know that we can exponentiate both sides, raise both sides to the a to get x by itself in a logarithm. So we're going to be using those properties every time we're doing this. We're going to start out with a couple of basic equations, a couple of basic exponential equations. These should be pretty easy. We have 4e to the 2x equals 16. So we're going to divide both sides by 4 to start out with. That gives us e to the 2x equals 4. Now, what undoes e to the x? We're going to take the natural log of both sides. That's going to cancel out the e, leaving us with just the exponent. 2x equals ln of 4. We don't know what ln of 4 is, but we're going to divide both sides by 2, and we're going to get that x equals the natural log of 4 divided by 2, which we can put in our calculator and find that that is approximately equal to 0.693. Usually I would rather have you give me exact answers rather than approximate answers, but it's really just going to depend on the problem. Okay, for this one, it's slightly more complicated, but still pretty simple all in all. 5e to the x plus 2 minus 8 equals 14. So, for this one, we are going to start out by adding 8 on both sides. That's going to give us 5e to the x plus 2 equals 22. Now we can't take the log of both sides until the exponential is by itself. So we need to divide both sides by the 5. That gives us e to the x plus 2 equals 22 over 5. And now the exponential is by itself. So now we can take the natural log of both sides. ln of e to the x plus 2 equals ln of 22 over 5. So now the ln and the e are gone. We have x plus 2 equals ln 22 over 5. X is almost by itself. We just need to subtract 2 on both sides, and x equals ln of 22 over 5 minus 2. That's 5. Okay? So again, pretty simple. Where it gets slightly more complicated is in problems like this. E to the 2x minus e to the x minus 20. All right, so this one is in quadratic form. Even though it's an exponential equation, sorry, this should be equals 0, so that it's an actual equation. Even though it's an exponential equation, it's in quadratic form. And we know that because e to the 2x is the same as e to the x squared from our power rules that we learned back in Algebra 2. So we're going to rewrite this as e to the x squared minus e to the x minus 20 equals 0. And this is a quadratic type equation that is factorable. Two numbers that multiply together to get negative 20 and add up to negative 1, negative 5, positive 4. This is e to the x minus 5 and e to the x plus 4 equals 0. So now we have two pieces. We're going to set each piece to 0 and solve for x. E to the x minus 5 equals 0, which means that e to the x equals 5. E to the x plus 4 equals 0, which means that e to the x equals negative 4. All right, but we don't care what e to the x equals. We want to know what x equals. So we're going to take the natural log of both sides. Ln of e to the x equals ln of 5, so that x equals ln of 5. Ln of e to the x equals ln of negative 4, but we remember that we cannot take the natural log of a negative number. So this part doesn't work. That part does not give us a valid answer to this equation. So our only solution is x equals the natural log of 5. And those are the main types of exponential equations that you're going to be dealing with in this section. The next video will be on the logarithmic equations.